everyone, and welcome back to Historian-splaining. A historian tells you why everything you know is wrong. Last month, after I was away for some time, I posted a couple of podcasts about my travels with my family in Britain. You can hear some of them on SoundCloud, iTunes, Stitcher, and other platforms for everyone. Others are posted only on Patreon for patrons only. And I expect that as much as I'm able, I'm going to pick up again on the courses of lectures that I had begun previously about the transition from the medieval to the modern world. And also I'll continue my series on the history of the United States in 100 objects and on myths of the month. And again, those will alternate, and you can hear some of them publicly and some of them you can hear if you go to Patreon and become a patron and contribute whatever you can, even if it's just $1 a month or $1 a lecture. So I spoke before about the general crisis of the 17th century, the sort of conditions of deprivation, conflict, warfare, disease that shaped Europe in the 1600s. And now I'm going to go back and talk about a long-term development in intellectual life, philosophy, high culture that eventually came to fruition in the 17th century, but that began and has roots much earlier. And it's a change that a lot of people, both scholars and especially lay people, tend to see as sort of the defining shift that gave us the modern world. And this is what we call the scientific revolution, okay, the beginning of science. Now, as you can probably guess if you've listened to other lectures of mine about religion and the Enlightenment, you can probably guess I'm going to say, there was no scientific revolution, this is just a meaningless phrase. And I'm certainly not the only historian to see things more or less this way, but still also to see some use in grouping together a series of changes into a kind of broad theme. And famously, the historian Stephen Shapin wrote a book on the scientific revolution, and he began the book with the sentence, "There was no scientific revolution, and this is a book about it." So you can see this kind of ambivalence built right into the way a lot of historians talk about the scientific revolution. And that's because it's clear that a change in thinking and a change of practices definitely did happen between about 1500 and 1800, more or less. And you even could extend it out a bit longer, back into the late Middle Ages and up through the early modern era, even into the Industrial Age. There was a shift in how people tried to understand and control and use natural phenomena, whether it was living creatures or their own bodies or tools or electricity. And more or less we can say that this gave rise to what we now call science. The problem is that people didn't use the word science in that way before about 1800. People, and I've found this in my own research, people talked about science to mean rituals, to mean art. Science simply meant any highly cultivated skill or practice, which might not fall under what we would consider science today at all, which might be more magical even than scientific. And indeed, disciplines like astrology and alchemy were very popular in the early modern era and were frequently referred to as sciences. So we can't look back at people in the 15 or 1600s and say, well, they were scientists or they were somehow giving rise to a scientific worldview. They were experimenting and trying out all kinds of different ideas, some of which we might then retroactively look back at and agree with or endorse, and hence try to call it science retrospectively. And we're constantly sort of reshaping and re-mythologizing our myth of science. And a really good example of this, I think you can see in the recent TV show with our hero, Neil deGrasse Tyson, called Cosmos, where Neil deGrasse Tyson and the writers of the show talk about Giordano Bruno. And Giordano Bruno is a figure you would have very, very rarely heard mentioned at all, much less in relation to science, say 20 or 30 years ago. And in fact, people who wrote about him, like Francis Yates, were mainly interested in Hermetic mysticism, meditation practices, and they didn't claim him as a scientist at all. But one of the teachings that got Giordano Bruno into trouble in the 1590s was his argument that there were other worlds similar to Earth, not only beyond Earth, but beyond the solar system and out in the stars. And he even hypothesized that the stars were other suns with other Earths going around them. And this was seen as a really nutty idea, and it's part of what got him in trouble with the Inquisition and eventually led to him being burned at the stake in Rome in 1600. Now, nonetheless, he's never been seen as a martyr of science per se, in the way that people might view, say, Galileo. But in recent years, astronomers and cosmologists have been discovering lots of new planets that we didn't know about, orbiting thousands of other stars all over the galaxy outside our solar system. So suddenly, in retrospect, now that we know what we know, Giordano Bruno looks a lot more sane, and hence he can be sort of reclaimed and celebrated and held up as a hero and martyr of science in our popular culture in a way he wasn't before. So this is just one little example of how our understanding of what we call science, what we call scientific, really just depends on what we consider to be true in our own time, and we sort of retrospectively pick out what we endorse and embrace as science. Nonetheless, we do have to say there was a paradigm shift that gradually happened after about 1500 for a variety of reasons. And people shifted, as I'll explain later, from a teleological worldview into really a period of confusion, an epistemic free-for-all, as Ewan Cameron calls it, that lasted at least until the late 1700s and then slowly was replaced by a new consensus, a mechanistic worldview. So there was a change from a teleological world to a mechanistic world. And before I get into what that means, I'll go back and say this phrase paradigm shift has a lot of baggage to it as well. So the historian Thomas Kuhn, in his book, The Structure of Scientific Revolutions, tried to figure out how socially and historically people go through shifts in their paradigm, their sort of overall explanation of the world and how you should understand it. And he found that paradigm shifts happen periodically in history, and there have been many all through antiquity and the Middle Ages. The scientific revolution is just one of them. And that they do not happen because people get more information. That's not the critical factor, that people have more evidence or more facts than they used to. Rather, people shift paradigms because the paradigm they're working in fails to address particular questions and particular problems that people are really invested in at that time. So if you are, say, really trying to figure out how is it that birds and insects fly, and your physics has no explanation for that, then you're going to get confused and frustrated and search for some alternative way of looking at the world that will solve that particular problem. It's not that people didn't know before that birds fly. Everybody's already been able to see that. It's when you get concerned with that specific question, then that can fuel a paradigm shift. And that's more or less what happened gradually in Europe and Western Christendom between about 1500 and 1800, where the old paradigm, which was teleological and rooted mainly in the teachings of Aristotle and Aristotle's disciples, could no longer address a series of pressing problems that people were very concerned about at that time. And those problems that I'll talk about in brief are the problem of the body and medicine, the problem of motion, why do objects move, and the problem of the heavens. What are the heavenly bodies and why do they behave the way they do? And the older teleological view of the world that had prevailed certainly throughout the intellectual class and the universities in the High and Late Middle Ages couldn't really convincingly address those questions. And what I'm going to talk about now is basically the first part of this process, how the older teleological view broke down, leading into a period of confusion, experimentation, and heated debate over how to properly learn about the world and control the world. And that runs from about 1500 to about 1660. The time of the Restoration in England. So that's what I'm going to cover today, and then probably at a later time I'll pick it up after 1660 and go on into the rise of Newtonian science. This period of breakdown and confusion was intellectually fertile and active, but it was not a time of innovation or inventions. There are very few, almost no significant technological inventions that came forward during this early part of the scientific revolution between 1500 and 1660. There were many important technological innovations in the High Middle Ages, things I've mentioned like spectacles, water and windmills, clocks, and there were also important inventions like riflery and lightning rods and steam engines that came later in the 17 and 1800s. But the period I'm talking about now is a period of intellectual ferment without much useful innovation. So the older teleological view of the world broke down. Okay, what does that mean? Well, teleological, the root of that word is the Greek word telos, which is a word that Aristotle uses a lot, and that's very important to his philosophy, and it basically means purpose or fulfillment. So in Aristotle's opinion, everything in the world has a given telos, a purpose that it is destined to fulfill. And you can understand the behavior of things if you know what their telos is. So why does an acorn sprout and become an oak tree? Because that is fundamental to its nature. That's its telos. And if everything is going right in the environment, if everything is safe and healthy, then that will happen. It will fulfill that end of sprouting into an oak tree. And if the oak tree is healthy and able to live, then it will fulfill its telos of creating more acorns, and so on. And only if something has gone wrong will the telos of a thing be interrupted. And everything you observe in the world, from the dirt in the ground, the water bubbling out of springs, the rocks, the animals and birds, the clouds in the air, everything has its given telos and fulfills its natural role. And that applies even to human beings. Human beings have a telos, and in Aristotle's view, that telos was to live in social communities and do things like engage in lawmaking, art, building, statesmanship, warfare. These are the special things humans do, and when a human is healthy and flourishing, he or she takes part in those distinctive human activities. So everything in the world can be explained according to the fulfillment or non-fulfillment of telos. And if things happen, it's because they're somehow moving towards those destined ends that are encoded into their nature. Now, the mechanistic worldview, by contrast, sees the world more like a machine. Things do things not because they're fulfilling some ultimate destiny, but because there's some immediate prior cause that made them happen, like a billiard ball striking another billiard ball and causing it to move, or a gear turning another gear next to it. And the more a person works with machines like clocks or mills, the more easy and intuitive it is to see things as working like machines, even including human beings and their bodies you might see as machines. So this is a very different view of the world. And instead of seeing the causes of events as lying in the future, what they're moving towards, instead you see causes as being in the immediate past. Right? A billiard ball hits another billiard ball, which falls into a pocket, right? So to distill the difference, the distinction between these two ways of explaining the world, I like to ask a question. As an example, why does the millstone turn? So, the millstone is a huge round stone that's in the middle of a mill that the mill drives and it grinds the grain. So if you ask why does the millstone turn, there are two different ways of approaching a question like that. One is to say, well, the millstone turns because there's water flowing into the water wheel, and the weight turns the wheel, which turns an axle, which turns a series of gears, which then turns the millstone. So you can explain the machine and what's driving it. An alternative way of answering the question, why does the millstone turn, is to say, in order to grind the grain. That's what it's there for. And either explanation is valid. And really, anytime we ask a why question, there's always that ambiguity to it of which sort of answer are you looking for when you ask why. And basically, intellectual philosophy, as taught in the Middle Ages, was looking for teleological answers. But this came drastically into question and was dramatically challenged through the 15 and early 1600s, and it took really centuries for the mechanistic view of the world to gain ascendancy and define what we now think of as proper science. So the three basic problems that I mentioned were problems of the type that Thomas Kuhn is talking about. They couldn't really be convincingly tackled using the inherited views of Aristotle and his followers. And the first of these I mentioned is the problem of the body. And this is a very important field of research today, actually, is disputed beliefs about the makeup of the body, about medicine, about health and sickness. And it's not something that people studied so much before about the 1980s. It's really a growing field today. And this has really drastically changed the way people talk about the scientific revolution and has complicated and, in a way, confused what people understand by the origins of science, because it's very entangled, for example, with alchemy and all kinds of other fields of inquiry that we today reject as not properly scientific. But historically, that distinction means nothing. So, as one historian said, and I don't remember their name right now, but I know that at least one historian has said that today, historians of science have accepted that the real first confrontation of the scientific revolution was not between Galileo and Ptolemy, but rather it was between Paracelsus and Galen. So, who was Paracelsus? Well, he was an alchemical doctor and physician who challenged the received wisdom and practices of medicine in late medieval Europe. His actual original name, he was German, and his actual name was Theophrastus Bombastus von Hohenheim. So you might wonder why someone with such a cool-sounding name would change it. Maybe it was for ease of spelling. But he took on the pseudonym Paracelsus, which means both against Celsus and equal to Celsus. And Celsus was another important ancient doctor, a follower of Galen. So he was declaring himself as the equal and the critic of the ancients, which was very daring. So the accepted authority on all medical matters, the sort of most fundamental canonical authority on medicine and the body, was Galen. And Galen was an ancient Greek philosopher, a follower of Aristotle, and Galen was the first to apply the basic idea of the four elements to the body. So there was this existing idea in ancient Greece, going back at least to Empedocles, that everything in the world boils down to four basic stuffs: earth, air, water, and fire, and each one behaves a little differently. And Galen basically argued that your body is made up of interacting humors, four substances or fluids that correspond to these four elements: blood, phlegm, yellow bile, and black bile, if I'm not mistaken. And each of those corresponds to one of the elements of the world. I don't remember exactly how each one fits, so I won't get into that. But the basic idea was that a healthy body is simply one that has the right balance of these four humors. And if you're having a health problem, it's because you have too much or too little of one of these humors. So one notion they had was that blood was the hot humor corresponding to fire. And if you had a fever, it was probably because you had too much blood. So this is part of why Galenic physicians all through the Middle Ages would bleed people who had fevers. And there are some ailments sometimes where that might help, but in general, if you have a fever because of an infection, you don't want to lose that blood, so it didn't really help. There also were other things, like if you have certain sorts of nausea, stomach ailments, they might give you purgatives. They might say, okay, you have too much of this or that type of bile. We need to give you a purgative so you vomit it out. Now, that in many cases might be helpful. If you have a stomach illness, purgatives can be good for you. So the basic situation is that they had this theory based around the four humors. They based their practices on that theory, and sometimes it might help, and sometimes it hurt more than it helped. And it really was very dicey going to an academic-trained physician. So Paracelsus was the first person to stand forward and directly challenge this philosophy openly. There were other people who didn't conform to it, sort of folk healers, witches who might be herbal healers, barber surgeons, people you would go to if you had an infected limb or a tooth, all kinds of non-university trained practitioners. And Paracelsus was very open about the fact that he learned from these people, and this was the root of his knowledge. And he said, I have not been ashamed to learn from tramps, butchers, and barbers. Paracelsus was born in 1493, and he served as a doctor for traveling Venetian mercenaries around Europe. So he had to deal with injuries and infections and camp diseases that spread in military camps. And as he traveled around, he sought out these people whom he thought might have important and useful knowledge. And he also he experimented, tried out different elixirs, potions, exercises, prayers, incantations, just to see what might work and what might build his sort of repertory of treatments. And in the course of his exploration and experimentation, he lost any faith in the Galenic explanation of the body, and he instead formulated his own alchemical theory of the body. So alchemy is a field with roots in the Middle Ages, and really even in the ancient world, but that exploded in popularity in the 15 and 1600s. And really it seems from the historical record that ultimately it was the 1600s that was the real golden age of alchemy. And one of the reasons was because it seemed to offer methods and avenues that traditional Aristotelian and Galenic philosophy did not. So alchemy technically is the study of the transmutation of substances. And the word comes from Arabic. There were, great Arab alchemists. And basically, if you accept the notion that the world is made up of four elements or some finite number of elements, then that leaves open the question, can you change one into another? Can earth change into fire, or vice versa? And alchemists were the people who explored and experimented with this possibility. And a lot of them, of course, were shysters. You can see in the Canterbury Tales, there's an alchemist figure who's clearly, a huckster. But in principle, it could be valid. There was nothing in the accepted academic philosophy that said alchemy was out of the question. And Paracelsus turned to the idea of alchemy and said, sometimes a tiny bit of some substance, of an herb or a chemical or a tiny action, can somehow completely change a person's health. It can change their body temperature. It can heal an infection. And he postulated it must be that there are chemical changes going on in the body. Elements can actually change from one to another. It's not just a matter of quantities, of put some in and take some out. It's a matter of changing the substances. And he put forward an alternative theory where he argued that the body had three basic elements, mercury, sulfur, and salt. And if I remember right, salt represents the sort of physical body, sulfur is the airy spiritual body, and mercury is what binds the two together. And you have to keep the spirit in the body, right, to keep someone alive. So his theory in that respect was no more scientific, in scare quotes, than Galen's. He still thought that there were these fundamental kind of invisible elements. But he tried out, he experimented, he explored different possibilities, and he maintained the idea that the tiniest material, the tiniest quantity of material can cause a kind of chain reaction. And he's the one who first postulated the dose makes the poison. The same material can have drastically different effects if you use it in different amounts, right? A tiny pill of something can save you, whereas a bowlful will kill you, right? So he opened up all kinds of new possibilities that the traditional Galenic physicians weren't thinking about. Now, all of this might make him seem rather smart, but he wouldn't have had such an impact except that in the year 1526, a printer in the city of Basel in Switzerland specifically called on him and asked him to come and treat his illness. And Paracelsus was able to cure this printer, and at the time there were other important intellectuals and philosophers in Basel affiliated with the University of Basel, including Desiderius Erasmus, the sort of prince of humanism. And these new friends were impressed with Paracelsus, and they were able to finagle him a position at the University of Basel. And once he got there, he sort of went on a campaign against traditional Galenic medicine. And he could be very aggressive and harsh about sort of the stupidity and ineffectiveness of these degree-holding doctors. And he said at one point, quote, "If disease puts us to the test, all our splendor, title, ring, and name will be as much help as a horse's tail." And he took several drastic actions, including opening up lectures of the Faculty of Medicine to anybody. So anyone from the general public could go and hear medical knowledge. He invited all sorts of people, these tramps and traveling healers, to come and teach, not only to study, but also to teach. And he declared that, quote, "The patients are your textbook, the sickbed is your study," and that scholars and doctors should throw out the inherited writings of the older philosophers. And his campaign culminated with a bonfire where he burned the books of Galen and other followers of Galen. So not surprisingly, this caused a lot of controversy and backlash. And after only 2 years, he was expelled from the university at Basel and went back to sort of traveling around Central Europe, spreading his ideas. So Paracelsus's episode at Basel sort of fueled a revolution in the field of medicine and the body. It encouraged people to take alchemy more seriously, to take folk knowledge and healing more seriously, to take experimentation more seriously, and to study the actual form and structure of the body more intensely, right? So instead of simply saying, well, there are 4 humors in there and all you have to worry about is just their quantities, instead people began in earnest to seek out bodies, open them up, dissect them, examine them, describe them, and figure out how to use that anatomical knowledge to the advantage of medicine. So this paved the way for Vesalius and Harvey, these later doctors who discovered the workings of the circulatory system, the respiratory system, and all these different interlocking, interdependent systems that perform the functions of the body. Not just piles of this or that humor. So this was the first big controversy that really spurred the period of anarchy that led the way for more intellectual debates and more of the classic episodes that we more often think of as the beginnings of science. So the problem of the body and of health had a lot of relevance in the late Middle Ages and into the 1500s because of infectious diseases like bubonic plague and smallpox, these crowd diseases that were a big increasing problem in that time. And another problem, the problem of motion, also came to the fore for different reasons, and that was mainly because of the gunpowder revolution and really the military revolution from the 1300s onward, where people were finding new ways to hurl and launch objects at one another. And they wanted to be able to tell if they could control and predict these motions. And the long accepted explanation of projectile motion came from Aristotle. And Aristotle put forward a sort of aerial theory of why do objects continue to move after you've let go of them and to fly through the air. And he theorized that when you throw or launch an object like a javelin into the air, it cuts through the air and leaves behind a vacuum, an empty space behind it. And air then rushes in to fill that empty space, and as it does so, it pushes the back of the object forward. So this is what Aristotle was able to come up with, and not surprisingly, a lot of people, even pretty early on, found this explanation unconvincing. And this was left as a kind of uncertain gap in people's explanation of the natural world. You could talk about falling objects in a teleological way. You could say, well, when I let go of a rock, it drops to the ground because it's seeking out its natural place. It's part of the earth. Whereas if steam is coming out of a pot, it rises because it is like the air and the clouds, and so it's seeking out its place upward. So you could explain a certain amount of motion that way, but projectile motion was still a big problem. And the first philosopher to tackle this and try to put forward what he considered a better theory was actually a medieval scholastic, Jean Buridan, who lived from 1295 to 1363, so in the sort of later years of the scholastic era in the High Middle Ages, and was a contemporary of William and Ockham and people like that. And he was known as a sort of outsized, colorful personality. He kind of jumped around from place to place, institution to institution, causing scandals. And he tried his hand at this question of, particularly of projectile motion. And he postulated that there was such a thing as some sort of substance or power that he called impetus, which you impart to an object when you launch it. So if you, say, throw a rock into the air, you're putting a certain amount of impetus into it, and that impetus stays with it until something draws it or bleeds it out. So it's going to continue moving until it, say, hits something, like a wall or water or the ground, and that thing that it hits then borrows or drains away that impetus until it's run out. And this is why, say, if you roll a bowling ball and it hits the ground, it'll keep going until it gradually slows. And the more impacts and the more friction it experiences, the more that impetus gets drained away. So Jean Buridan's theory of impetus actually, you can probably tell, paved the way for all of these later developments like Newton's laws of motion. You know, his first law of motion is an object in motion tends to stay in motion unless it's acted upon. And it also anticipates later theories like the idea of kinetic energy, which would only be, formally theorized much later in the 18th and 19th centuries. But Buridan kind of got the ball rolling, you could say, in a sense, in reworking and approaching this whole question in a different way. But it wasn't really examined and experimented with in a systematic way to test whether there really is an impetus until Galileo. So this was the first problem that Galileo tackled that made him a significant philosophical figure. And Galileo, of course, was an Italian from Florence. He had patrons and supporters in Florence, including the Medici family. He was born 1564, so, just over 200 years after Jean Buridan had died. And he saw this problem of motion as ripe for a new analysis. And the way he went about it was very significant, because Galileo, by training, was a mathematician. And mathematicians at this time were not necessarily seen as very high status or prestigious intellects. They were seen as kind of artisans, tinkerers, people who could solve little practical problems with numbers. They were not taken as seriously, and they did not have the prestige of university-trained philosophers and theologians, who of course were at the highest rung of the kind of intellectual ladder. And Galileo wanted to move up. So he was a very good mathematician, but he decided that he wanted to try to work his way up in the status hierarchy in the intellectual scene of Florence and of Europe more generally. So he decided to apply his mathematical analyses to difficult philosophical problems that people saw in the works of Aristotle and in these accepted canons of philosophy. And he later moved on from that to other problems too, which I'll get to later. But when it came to the problem of motion, he basically reasoned that if Buridan was right, that when you move an object, you put an impetus into it, which then gradually drains away. He then figured that if nothing is stopping or inhibiting the object and taking that impetus out of it, it should, in theory, keep moving forever. And he tried different experiments with rolling balls on ramps, rolling them onto tables, and seeing how far a ball could continue rolling and keeping up its speed, and whether it was true that with an ideal situation, as you reduce and reduce the friction, the ball can keep rolling further and further without losing speed. And in order to do this, he had to measure the motions of objects very precisely. He had to trace their paths and their speeds at different positions and points in time, and he analyzed these motions mathematically. And among the things he found was that he could measure motion most precisely and almost prove that Buridan was right, that without friction it would move forever, if he allowed things to fall. If he basically said, okay, allow the ball to roll right off the table and start falling, and see and trace its path as it falls. And he found that the path of a falling object that rolls off an edge like that traces a parabola, a perfectly mathematically describable shape. And that this meant that the motion of the object was perfectly mathematically describable and predictable if the friction was negligible, close to zero, which is basically what it is when you have a dense object like a marble or a bowling ball in free fall. And from here he was able to further reason that a falling object, the speed of its fall and its path is also perfectly mathematically predictable. And he came to the conclusion that all objects, regardless of their size, their weight, their shape, all objects fall in the same way. They all have a regular rate of acceleration as they fall. So you can take a marble, a chair, a feather, your napkin, whatever it is, hold it in the air, let go of it. It's going to start out motionless, and then it's going to accelerate at a regular, steady rate until it stops accelerating because of friction with the air. And he made the argument. He never, as far as we know, there's no record of him ever actually performing this experiment, because he knew that it wouldn't really work the way it ought to ideally. But he made the argument that if you take two objects like a a lawn bowling ball and a feather, and you went up the Leaning Tower of Pisa and dropped both of them off at the same moment, released them at the same moment, they would both fall accelerating at exactly the same rate. And the hitch is just that the feather will stop accelerating fairly quickly because it has more air drag, more air friction pushing back against it than the bowling ball does. But if you had, say, two balls, like two bowling balls of different weights and different sizes, and you drop them, they should accelerate basically the same and hit the ground at more or less the same time. So this basically, if Galileo was right, it would force people to throw out Aristotle's explanation about motion, where he says that things move in different directions in different ways because they're seeking out their natural place. Instead, Galileo, using his mathematical modeling, made a strong case that actually everything falls. It doesn't matter what it is. The substance of it doesn't matter. It doesn't matter if it's made of horn or bone or stone or ice or whatever. Everything is moving in the same way, acted upon apparently by some unchanging universal force of gravity. So Galileo, again, in this way you could say he anticipated Newton and the idea of universal gravitation, but really more fundamentally than that, he seemed to demonstrate that strange phenomena, complicated differences between objects and materials actually can be reduced down to mathematics if you can do the math. So, not surprisingly, after having made this advance, Galileo then moved on to, you might say, a higher realm, literally and figuratively. He turned his attention to the heavens. So the heavens traditionally were believed to be the most pure, most uncorrupted, most divine aspect of the universe. And to study the heavens was to make you, in a sense, the highest rank of philosopher. You were the philosopher closest to an understanding of the sort of divine structure of the world. And so attacking the questions of the heavens, why do heavenly bodies move the way they do? Why do they behave the way they do? What are they made of? How do they relate to the earth? These were highly sensitive questions, and the accepted theory of the universe through the High and Late Middle Ages was Ptolemy's Almagest. So Ptolemy was another late antique philosopher who was a follower of Aristotle. And as Galen tried to apply Aristotle and other philosophers' theories to the body, so Ptolemy applied them to the cosmos. And his book, The Almagest, was the sort of accepted canon on astronomy in the medieval world, and it was geocentric. So Ptolemy argued that the Earth was a round sphere, and again, all philosophers through the late antiquity and the Middle Ages all agreed that clearly the Earth is round. He argued that the Earth was a sphere at the center of the universe, and that the heavenly bodies were affixed to different outer spheres that rotated in different patterns around the Earth. And the stars, for instance, were very simple to explain because they were all just attached to a single sphere rotating in a simple circle around the Earth. Whereas there were other heavenly bodies, like the moon and especially the planets, that showed more complex motions. And planet actually means wandering star originally. So these bodies don't just move in a simple loop. They go in sort of weird loop-de-loops, depending on the time of day, the time of the year, the time of the month. And Ptolemy was able to explain these strange, more complicated motions through what he called epicycles. So if you imagine you take a planet like Mars and you path its sort of looping curlicue path through the sky, you can say, well, what's happening is Mars is moving around some central point in the sky, and that point is in turn going around the Earth. So it's doing sort of a circle around a circle, so to speak. It's a little hard to explain without a picture, but these more complicated epicycles seem to be giving reasonably good, sort of close enough predictions and descriptions of where the heavenly bodies are going to appear. And this is what people referred to for centuries. But this left some people unsatisfied, naturally enough. So the idea that there was some simpler explanation for why the planets moved in their strange paths surfaced from time to time, and the first person to put down an extended argument for an alternative explanation was Nicolaus Copernicus, who was a German-Polish priest, and he wrote a book on the revolutions of the heavenly spheres in 1543. So he challenged Ptolemy's geocentric theory and put forward a heliocentric theory of the universe, with the sun at the center. And he argued that, in fact, you could explain these complicated, strange motions of the planets if you simply reoriented your conception of what the planets are and what Earth is, and you say that the planets and the Earth are just bodies all rotating around the sun. So this theory had some advantages to it. For one thing, it seemed to offer a nice, simple picture of at least a part of the cosmos that wasn't as sort of mathematically or visually complicated as Ptolemy's. It also put the sun at the center, and if you were a believer in astrology and alchemy, as Copernicus was, and as Galileo was too, as it happens, then it was appealing to think of the sun as being at the center. So the sun is associated in alchemy and astrology with gold. It is seen as corresponding to the most eternal and immortal substances, and as a kind of life-giving force that animates and energizes the universe. And so Copernicus, as he said in the introduction to his book, he liked the idea of having the sun at the center. It seemed more natural. He didn't have it published, and the theory did not become canonical or widely accepted because it caused certain problems. So Ptolemy's Almagest and his theory of the universe had been adopted into church teachings and the orthodoxy of the Western Church for various reasons. It had a sort of theological overlay had been put over it. The church and Western philosophy in general liked the idea of the earth at the center because, in their view, the earth was the most base, the most corrupted, the lowliest aspect of the universe. And human beings who are sinful and mortal and corrupt are sort of stuck on the earth, whereas we are only able to look up into the heavens and see what is eternal and uncorrupted. So they saw a basic divide, and the moon was sort of the dividing point. Everything below the moon was mortal and corrupt and suffered changes like earthquakes and storms and floods and disease and death, whereas above the moon you had a celestial world where everything was eternal and perfect. So the heavenly bodies, in their view, were perfectly circular, they were unchanging, they followed perfect mathematical, unchanging paths through the sky. And so it is not the case, as some people incorrectly say, that in the Middle Ages people put the earth at the center because they thought the earth was special or better. Quite the opposite. They saw the earth as lower and as sort of base materials accumulating on the earth in sort of the same way that if you take a bucket of seawater or a dirty old pot and you spin it around so the water is spinning, the sort of gunk and grime will collect in the center. You may have seen that happen. That's how they thought of the earth. So the problem philosophically and theologically with Copernicus's heliocentric theory was that it put the sun at the center, and it imagined the earth as being a planet and hence another heavenly body. like the other heavenly bodies. And in this sense, this theory of Copernicus's was appealing to people who liked the idea of elevating humankind and putting human beings and the earth into the heavens alongside the other celestial bodies. And Galileo liked this idea. He was one of the sort of iconoclastic, ambitious thinkers who heard of and was attracted to the Copernican theory. And he set about trying to see if he could demonstrate it again using his math. So he made observations of the sky and the motions of the heavenly bodies. He tested them to see how precisely they fit Ptolemy's theory. He corresponded with other astronomers around Europe, like Tycho Brahe, who were making very precise systematic observations of the heavens and trying to see whether or not they could accord with Ptolemy's Almagest. But his breakthrough came thanks to optics. So in the early 1600s, glassmakers in Venice began making a stronger form of glass that had not been produced before, and that could be ground down into much more powerfully magnifying and precise lenses than had been possible before. So if we look at the Middle Ages, philosophers like Francis Bacon did study optics, sometimes very insightfully, and they did produce certain optic instruments like magnifying glasses and spectacles, but nothing powerful enough to make what we would call a microscope or a telescope. And it seems that in Venice, as sailors and mariners got hold of this better Venetian glass, they started making spy glasses that could magnify farther off and see, for example, enemy ships approaching on the horizon or arriving in the harbor. And Galileo, so far as we know, was the first to make compound telescopes, where he would take several of these stronger lenses and stick them together on a long extending tube, so as to multiply their magnifying power. And he used this telescope to start looking at the night sky and at the heavenly bodies. And he made a number of very important, impactful observations, which he then collected and published in a book called The Starry Messenger in 1610. And The Starry Messenger put forward several potentially revolutionary observations that Galileo had made, if people believed that they were valid. One was of the moon. So he observed that the moon was not actually a perfect smooth sphere like traditionally people had imagined all the heavenly bodies to be. Rather, if you looked at the sort of edge of the moon, of the visible illuminated portion of the moon, where the lights and shadows came out in clearer relief, you could see that the moon had some flat areas as well as mountains, cliffs, ravines, and craters, just like the Earth did, but really was even more rugged in its terrain, so to speak, than the Earth. And this meant that the moon was not a perfect sphere. It was actually probably changing and corruptible in the same way that the Earth was, and that it had events like earthquakes and asteroid impacts, like the Earth, that had created these imperfect asymmetrical features on the moon. Another observation was of the planet Venus. If you look close enough at the planet Venus, it doesn't just become lighter or dimmer at different times, it actually has phases. It becomes a crescent or a half Venus or a full Venus at different times. And this means that even beyond the moon, the planets also have changes. And thirdly, he observed the planet Jupiter, and he was able to see, with the magnification of his telescope, that there were 4 moons orbiting around Jupiter. We now know that there are more. I think that there are like a dozen or more moons going around Jupiter, but there are 4 really big ones, Io, Ganymede, Callisto, and Europa. And each of those is almost as big as the Earth, and you can see them pretty easily with any standard telescope. and you can observe them going around Jupiter and appearing in different points in their orbit as the days and weeks and months go by. And this was very important because it meant that not everything is rotating around the Earth, right? There are some heavenly bodies rotating around each other in different, differing overlapping patterns. The Earth isn't the center of all orbits. So all of these observations pointed to new facts or new ideas that were unacceptable according to the older Ptolemaic worldview. One is that there isn't a fundamental difference between the earth and the heavens, where one is eternal and unchanging and the other is changing. It also means everything isn't moving around the earth at the center of things. So these observations were very consciously intended to help break down these underpinnings of the Ptolemaic worldview and open the door for Copernicus's alternative explanation, where the Earth and the other planets are all similarly orbiting around the Sun, and then the Moon is going around the Earth and other moons are going around other planets. So after this point, Galileo caused a bit of a stir, but there was a lot of pushback. A lot of philosophers argued that they couldn't trust this telescope. The telescope is an instrument that distorts our vision, and hence we shouldn't trust it over the plain observations of our own eyes. And from their point of view, that was a reasonable, rational, logical response to Galileo's arguments, to say that the fact that the telescope magnifies doesn't mean that it's giving you a more correct or reliable view of things than your own direct observations. And basically the intellectual community was split, and there was controversy over Galileo's observations and over his arguments in support of Copernicus's theory. But Galileo pressed forward. He made mathematical observations and analyses that refined and adjusted Copernicus's argument, and that gave a more precise mathematical explanation of the orbits of the planets. He was, of course, helped in tandem by Tycho Brahe and others who, like him, were trained mathematicians. And in 1632, he published another book called The Dialogue of the Two World Systems, which laid out his argument in very aggressive terms. So Galileo had gotten in a bit of trouble with the church. The church did not approve of or embrace his teachings, but Galileo very aggressively campaigned for his views because he was a devout Catholic, and he wanted the church to teach what he believed to be true doctrine and not false doctrine. So he didn't give up on his quest, and in response, eventually the church came to what they considered to be a reasonable compromise, where they said Galileo and his supporters may teach his theories as a hypothesis. And they did not use the word hypothesis in the way that we do today. They didn't mean as a sort of guess. They meant it's acceptable as a hypothesis, meaning as a mathematical model or mental model to describe how things move, but not as a purported explanation of reality. So basically they didn't want people to say that this really is how the universe works, but it's acceptable just as a kind of mathematical formula for predicting the motions of the heavens. And Galileo was not satisfied with this. So in his Dialogue of the Two World Systems, published in 1632, he put forward an imaginary dialogue between two characters, which was a common thing to do at that time when you're making an argument. It's sort of modeled on Plato's dialogues, things like that. And in the dialogue, you have one character who clearly is based on Galileo himself, arguing for Copernicus's world system. And then you have another character called Simplicius, meaning sort of simpleton or simple-minded, trying to defend the Ptolemaic world system against these better arguments. And the character of Simplicius not only is clearly dumb, but you can also see in the words and phrases that he uses and his sort of style that he's clearly meant as a satire of the Pope. So Galileo was pretty clearly mocking and attacking the Pope in this book. And this may have been the last straw that finally got him in trouble with the Inquisition. Now, there also were other factors at work. The patrons, the powerful patrons who had been supporting and sponsoring him in Florence, fell out of favor, lost much of their power, and weren't able to protect Galileo anymore as they had. And so there was a sort of perfect storm that led to him being arrested and questioned by the Inquisition in 1633 and forced to disavow his book and recant his arguments. He was threatened with torture, and under that threat, he did agree to say, "It does not move," in reference to the earth. So this was the crucial point that the church sort of brought the hammer down upon, was the idea of the earth moving through the universe. And the argument that the church used against Galileo was not that was not in defense of Ptolemy's system, and it was not on any particular point about the planets or the stars or the sun or anything like that. It was that they found verses in the Bible that describe the earth being still and the sun moving around it, or the sun moving through the sky. And they considered Copernicus's argument to be blasphemous and heretical because it postulated that the sun stays still and the earth moves. Ironically today, cosmologists would say, well, they both move because the sun's moving through the galaxy. But nonetheless, this was the sticking point. And it's very significant that at this time, the 1600s were the biblical century, as historians now call it. This was a time when in both the Catholic Church and the Protestant world, people were taking Scripture very seriously and much more literally than they had before. So whereas in the Middle Ages, people might be arguing over the fine points of philosophy and theology, in the 1600s it came down to, are you on the right side of the Bible and Scripture? That was the ultimate test. And Galileo was condemned for contradicting Scripture as they understood it, and he agreed to relent and recant on that point and to agree that the earth does not move. So this was a bit of an embarrassing episode, really on all sides. It was an embarrassing episode for Galileo, that he did not become a martyr for his philosophy in the way that, say, Giordano Bruno was in 1600. And for that reason, he's never been held up as such a hero of science as other later figures might be, because you could say he, cracked under pressure, though I and most people probably, would not blame him for relenting on that one point under threat by the Inquisition. It also became an embarrassing episode for the church. It showed a great insecurity in the church's own beliefs, that they were so threatened by Galileo and his arguments, and it's something that the church has had to sort of avoid talking about and sort of half-heartedly disavow in later centuries. And naturally, Galileo's arguments have since that time been adopted into Catholic teachings, as have other theories like the theory of evolution, but that, of course, is much later. So under this kind of three-pronged attack of the problem of the body and the new Paracelsian and alchemical understanding of the body, the new explanations of motion as a mathematically describable pattern, and under this new explanation of the heavens and the cosmos, the old Aristotelian worldview was really in shambles. And it was really in only very sort of closed-minded orthodox circles, and in respect to particular problems and subject areas, that some people still tried to cling to the medieval scholastic Aristotelian philosophy. And in the absence of that kind of overarching orthodox consensus about the world, you got a sort of flood of new alternative epistemologies vying for attention and vying for followers. Some of them were inspired by ancient philosophies that were being rediscovered in manuscripts, translated, circulated, published anew, and introduced to new audiences. An example of this is the arguments of Lucretius, who actually argued that the universe had no center at all. So Lucretius was an ancient Greek philosopher who was not avowedly heliocentric or geocentric, but who instead argued that the universe was infinite, extended in all directions, and hence had no special center and no special privileged frame of reference. There was no point of view from which you could say this or that object is moving in this or that direction. It was all a matter of point of view. So in this way, you could see him as almost anticipating relativity. And the sort of radical skepticism and relativism of Lucretius influenced a lot of the more extreme new thinkers in the 15 and 1600s. There also was a surge of Neoplatonism. So some of Plato's dialogues had more kind of kooky metaphysical ideas, particularly the Timaeus, that posits a kind of mystical tie or relationship between the microcosm and the macrocosm. So this is very different from Lucretius's philosophy. But in certain writings of Plato, he posits that the visible world that we experience every day, like a home, a body, a town, is a microcosm or small cosmos that has hidden correspondences to the macrocosm, the bigger universe, and that you can somehow mathematically or experimentally study these correspondences. And some of these sort of ideas had a lot of currency in the Middle Ages, like the notion that the sun somehow corresponds to gold and the moon corresponds to silver. So these sort of Platonic ideas are underpinnings of alchemy and astrology. But they had a resurgence during the Renaissance because, well, for various reasons, one of them being the rediscovery of a set of mystical manuscripts and dialogues called the Corpus Hermeticum that had actually been written in late antiquity, so in the 3rd and 4th centuries, by mystical cults, especially in Egypt, that were then lost and unstudied and unknown for centuries until the 1400s, when a collection of this Corpus Hermeticum was brought to Florence, and a group of philosophers in Florence, including Marsilio Ficino and Giovanni Pico della Mirandola, started to translate them into Latin and circulate them widely. And they mistakenly thought that this Corpus Hermeticum was actually more ancient than Plato. They put aside their studies and translations of Plato and focused on this Corpus Hermeticum. And they caused a kind of sensation where people thought of this corpus as a forerunner, a sort of model of ancient, pristine Christian beliefs predating Christ himself, and also a forerunner of Plato and the ancient canonical Greek philosophers. And this study of the Corpus Hermeticum and of this sort of new version of Neoplatonism influenced all sorts of people all the way up through the 16 and 1700s. People I've mentioned like Giordano Bruno, and later Newton and Robert Boyle, and all of these sort of heroes that we think of as scientists were also mystics and hermeticists. Also, on the heels of this Neoplatonic sensation came Descartes. So Descartes was aware of some of these ideas circulating around Europe. He also was an artisan who dealt in artillery, right, and dealt with these problems of chemicals, chemical reactions, projectile motion, all of these sort of new problems that people were determined to grapple with. And Descartes, like a lot of people, was probably very confused. He had a lot of doubts about what he'd been taught in his schooling, about the accepted Aristotelian scholastic view of the world, and he reached a kind of crisis. And according to his own writings, while he was traveling, working with mercenary armies, a lot like Paracelsus did, he had a kind of crisis of faith, and he locked himself inside a large brick oven for several days. And he wrestled with his doubt, contemplating the idea that not only what he had been taught was wrong, but that maybe everything he knew and everything he saw was all an illusion that had been presented to his senses by a kind of evil trickster demon. And he wrestled with this kind of existential, totalizing doubt until he'd come to some sort of solution that satisfied him. And he began, according to his own account, he began by saying, well, I know that I exist because I'm sitting here thinking. So I think, therefore I am. And if I exist, then I know something exists, and something brought me into existence. And from there he reasoned that there must be a creator, a deity of some sort, who had created the universe, and that this universe must work according to some sort of rules or patterns. And he believed that the world could be observed and analyzed, much like Galileo at the same time. He went to the extreme, saying, well, the world can all be observed and analyzed and explained mathematically. And he invented what we, of course, call the Cartesian plane, this sort of mentally visualized alternative universe where everything sits in a definable position on a grid. And through this he invented Cartesian geometry and this sort of whole system of reasoning where you can kind of, if you are a realist like Descartes was, where you can believe that the whole world can somehow be described according to a sort of perfect imaginary mathematical scheme. So Descartes caused another sensation, sort of following after the rise of Neoplatonism, and appealed to a lot of the same people who likewise wanted to believe that through meditation and mathematics, you could model the world and reduce it down to rationally explainable problems. And some historians like Matt Jones have even argued that Descartes and his geometry are just really another form of meditation, of sort of spiritual contemplation, a lot like Hermetic meditation that Giordano Bruno and others like him were engaging in. A lot of these philosophers were themselves artisans. Like I mentioned, Descartes was working on fortifications and gunnery and things like this. And even those who were not came to be heavily influenced by the knowledge and techniques and mentalities of artisans. So whereas Descartes is sometimes held up as a sort of arch-rationalist, on the other side, Francis Bacon tends to be seen as an empiricist who was interested in observation and in using the senses. However, Bacon turned to the knowledge and techniques of artisans like smiths and folk healers and woodworkers and stone builders and all of these people who were constantly using their bodies and their senses to understand materials and manipulate them. So the sort of new power that people wanted, they saw that artisans already had in some way or some form. And artisans, on their part, many of them admired and borrowed from the philosophies of Paracelsus. Others had alternative but somewhat similar philosophies involving alchemy and astrology and the sort of hidden powers of the body and correspondences. And some artisans actually held up a sort of messianic idea, the notion that a prophet was at some point in the future going to return and reveal all the hidden secrets of nature. And they called this figure Elias Artista, or Elijah the Artisan. So if you look in the Bible, the prophet Elijah is unusual because he does not die according to the strictly literal word of the Old Testament. Rather, he ascends bodily into the heavens. And there's long been an idea among both Jews and Christians that at some point Elijah will return and will deliver new prophecies. And Jews have traditionally taught that Elijah will herald the coming of the Messiah. Some Christians took up this idea and believed that Elijah would return and herald the second coming of Christ. And again, this is the sort of messianic thinking that was very common in the early modern world, and especially in the 1600s. And I talked about this in my lecture on the general crisis of the 17th century. So this idea of alias artista, it fused together this sort of messianic expectation and excitement of the 1600s with this new interest in artisanal knowledge and the sort of the hidden secrets of nature that artisans could manipulate. So a lot of these philosophers, as well as doctors and other learned professionals, embraced this idea of alias artista. And alias artista was, you might say, a sort of symbol of the hope that went into a whole pansophical movement in the 1600s. So pansophical means universal knowledge. And a lot of these philosophers, like Francis Bacon, actually believed that this sort of return of Elijah or this new messianic world, this new future millennium, would be possible once all the knowledge of all people all around the world was gathered together in one place. And Bacon actually argued for the creation of a sort of universal academy to gather all knowledge from around the world. And he, in his Novum Organum in 1620, he argued against the old Aristotelian learning and proposed a new metaphysics and a new epistemology using the body in the same sort of way that artisans used their body to experiment and collect knowledge. One part of this book, Novum Organum, which he published in 1620, is called the Instauratio Magna, or Great Instauration. And that's a sort of old archaic term meaning restoration. And he believed that the secrets of the world, the secrets of the ancients, like the Corpus Hermeticum, were going to be revealed again once this new academy had been created. But he really most vividly illustrated this hope, this sort of millennial utopian hope of his, in another book, a short unfinished novel called The New Atlantis, which is somewhat like Thomas More's Utopia in that it imagines a sort of perfect island kingdom. But in this island kingdom called Ben Salem, this fictitious kingdom, there is a sort of secretive academy called the House of Solomon, which is really like a modern research university. Bacon was sort of imagining the prototype of a research university where philosophers would experiment with mines in the earth and chemicals and plants and experimental gardens, all within a sort of closed, secretive academy that would be the governing body of this perfect kingdom. So Bacon was sort of imagining a sort of pansophical future world in this new Atlantis. Similarly, the Czech philosopher Comenius put forward the idea that not only should all knowledge be gathered together in a single university, but that all people should then be educated in that knowledge. And that, in a way, is the part of Comenius that stuck. So he started out, he was a radical Anabaptist Protestant, so he came from this sort of fringe of the Radical Reformation, but he was able to start setting up a public schooling system that would educate both boys and girls in his native Bohemia. He then went on to Sweden and instituted a similar public education system in Sweden, sponsored by sympathetic Swedish rulers, including Queen Christina, who, as I mentioned again in the lecture on the 17th century, saw herself as playing a role in this coming messianic apocalyptic moment in the mid-1600s. And then a lot of Comenius's ideas and programs then made their way from Sweden to England. So again, this triangle of Bohemia, Sweden, and England. And during the English Civil War, when there was this outbreak of uncensored apocalypticism and millennialism, the independents, the Fifth Monarchy men, the diggers, the levelers, some of them took in some of these radical pansophical ideas from the European continent and from Sweden and gave them an audience. And one particular Swedish philosopher, Samuel Hartlib, actually fled wars and conflicts, ended up in England in the 1650s during the Cromwell interregnum period, and he began organizing circles of radical philosophers who embraced alchemical thought, Paracelsian, millennialism, and Hermeticism, and started organizing them and trying to promote the idea of forming a sort of universal pansophical academy, like the ones that Francis Bacon had imagined. A lot of them drew on biblical prophecies. Again, this was the biblical century, and they looked to prophecies, especially in the book of Daniel, that postulated that there would be a future fifth monarchy in which not only would the world be reformed and a sort of divine rule, kingdom of God be instituted, but that, again, all the secrets of nature would be revealed. So you see how all these interlocking ideas, they share all these strange echoes and points of contact. And this circle around Samuel Hartlib did form what some people called at the time an invisible college. And we don't know exactly how organized or formal this invisible college was. We don't know exactly who was a member and who was not, but they had at least a regular correspondence and at least aspired to have a permanent institution with standing in the kingdom, sort of like Bacon's, Solomon's house in the New Atlantis. And we know that certain important thinkers like Robert Boyle were members and referred to themselves as participating in this invisible college. But again, we don't know exactly how far it got. And these sort of radical ideas that were so much in the air and generating so much excitement in this interregnum period in England would not go away. Some of them would be suppressed, but some of them actually would find institutional expression and permanent standing after the Restoration, when the monarchy returned in 1660. And that is where I'll leave off, and I'll pick up the story later, probably in another lecture, when I hopefully get to it, about how these strange ideas fed into what became the Royal Society and the first sort of scientific organization like we would think of today. So the roots of what we think of now as science are not just Newton and Boyle and the Royal Society, but they're this deeper stream of often mystical and alchemical thought and messianic thought going back to the interregnum period and to the many confused, chaotic years of intellectual ferment before that. Now, this period of ferment did not, as I've said before, it did not lead straight into what we would think of as modern science and a mechanistic view of the world, where everything is governed by regular laws of cause and effect. It didn't lead to that, but it did, these earlier years of the scientific revolution did have an important impact and did, I think, effect an important shift in thinking that crosses the boundaries between philosophy and politics and art. And that basic shift is what I've talked about before, where reality, instead of being social, instead is sensory. So by 1660, people both in these high elite philosophical circles and it seems in more regular life we're no longer thinking of reality as fundamentally social and defined by your social relationships. So if you had been walking around in, say, 1400 and asked, how do I know what's real and what's true? People would tell you, well, go to a trusted teacher. Go to a doctor of the church, a doctor of the university. Go to Paris or Heidelberg or Oxford and talk to someone who is learned. And they will tell you about knowledge that has been verified by respected authorities. And the way you saw the world was and ought to be shaped by your social relationships. And if you look at the art of the Middle Ages, for example, you will see icons, flat sort of idealized images of people, of saints, of kings and queens, of the nine worthies. They don't appeal to your sort of sense of touch, or they don't seem lifelike. They don't seem like they could get up and start moving and walking around. They look like flat, idealized images, and the way you recognize them is by signs of their station, right? Their crown, if they're a ruler, their holy object, if they're a saint. And this is how you make sense of things around you, is by social symbols representing social relationships. By 1660 or so, people are now looking to their senses. They're saying, how do I know what's real? It's by what I see, by what I touch, by what I smell. And people are making precise observations of the world through their senses. And you see this not just in philosophy and the exploration of artisanal knowledge and things like this. You also see it in the art that people made. Now people are depicting one another and depicting scenes of their homes, of their countries, that are extremely detailed and lifelike, that show the precise details of light and shadow and color and texture. And so people are now showing their wisdom not by who they know or who they've read or who they're discipled to, but rather how they can master precise observation and recreating what they see and encounter around them in the world. And this is this same sort of shift, this fundamental shift that certain people sometimes realized consciously was happening in the world, and that I think you see dramatized again in Don Quixote, that I've talked about before. How now, at the end of Don Quixote, the hero accepts that things are what they appear to be. The windmill really is a windmill. The brothel really is a brothel, not a castle. The prostitute is a prostitute, not a princess. Right? Things are not what they ought to be according to some social scheme. They are what they seem to be according to the senses, right? And this is this shift that I think has happened, and that will allow the sort of rebuilding of a new view of the world and a new consensus after 1660. So thank you so much for listening. As I said, there will be more lectures on the early modern world, and I'll try to keep up and continue my series on the history of the United States in 100 objects and on myths of the month. And some of those will be open and available to everyone, and some of them will be for patrons. So please, if there's any way you can offer any support, even if it's just $1, please go to my Patreon page, also under Historiansplaining. And if you have questions, reactions, things you want to hear about, please do contact me at historiansplaining@gmail.com or comment on SoundCloud. Thank you.